Hello everyone, this is a demonstration of PostgreSQL Upgrade on a generic Linux distribution for the best practices and concepts. For this demonstration, I have a Postgres 11 environment with a primary and a standby. I am connected to the primary host and the secondary host. One best practice is to add the locations into your shell profile. In this case, the pg data old is pointing to the current data directory, which is of Postgres 11, and the pg data new is pointing to the new location because we are planning to upgrade to Postgres 16, and the pg bin old is pointing to the Postgres 11 binary location, and the new, pg bin new, is pointing to the new binary location of PostgreSQL 16. And this is important because the utilities like pg upgrade understands these environment variables. Before starting the upgrade, we should make sure that there is no replication lag. Then we need to make sure that PostgreSQL binary packages for the newer version also installed onto the same machine, and that need to be performed on both primary as well as standby. In this case, we can see that we have PostgreSQL 16 server as well as their client components are already installed, but the server is still running PostgreSQL 11. Everything discussed so far can be considered as pre-migration steps, and during the migration window, the downtime window, we can just shut down PostgreSQL and perform the upgrade. But for PG upgrade, we need a seed PostgreSQL instance to be created. Then proceed to shut down the PostgreSQL instance and perform the PG upgrade. In this case, I am using the hard link option. As we can see, we don't have to specify any other parameters during the PG upgrade because those parameters are already part of the environment variable which we set in our shell profile. Once the primary upgrade is completed, we can go ahead and shut down the standby and synchronize the standby with the upgraded primary. Basically, this is how we upgrade the standby. Instead of running PG upgrade on standby, this is how we can upgrade the standby by just rsyncing that with the primary. This rsync will be really quick because it does the same hard link manipulation on the standby side as the PG upgrade done on the primary side. And once the rsync is completed, we should be able to see that the data directory of new version is populated with a new set of hard links. Both primary and standby are upgraded now. Now we can go ahead and add a few PGHB entries for the primary side so that the standby can connect to the primary. And make sure that essential parameters like listen address are also taken care on the primary so that it will allow connections from the standby as well as the clients. Now the primary can be started up and given to applications to connect to it and start using it. Then proceed to standby and create a standby.signal file in the data directory and Then make sure that essential parameters like primary con info, the primary connection string, is placed in the parameters. And yeah, that's it. And now the system is ready to start up. And the standby is started using PGCTL, and it started up, and it tells us that it is streaming the val from the primary, so it's in sync with the primary. From the primary side, we can check and confirm that the standby is replicating and everything is in sync. So the upgrade is completed to PostgreSQL new version, which is 16 in this case.